Pluto is a far-off and somewhat mysterious celestial object, once regarded as a member of our close planetary group. However, recent controversial statements by prominent astrophysicists, Neil deGrasse Tyson and Michio Kaku, have brought Pluto back into the spotlight. They suggested that this icy dwarf planet might be on a possible collision path with Neptune. But how could such a catastrophic event occur, and what would the impact of such an extraordinary crash be? Is this an example of unpredictable cosmic behavior, or is there something more significant involved? Join us as we explore the potential outcomes of a Pluto-Neptune collision. Once categorized as a planet, Pluto, later reclassified as a dwarf planet, continues to intrigue astronomers and space enthusiasts alike. Recently, leading experts have voiced concerns about Pluto's closeness to Neptune and the chance of a catastrophic crash between the two. But how plausible is this potential scenario? Pluto's orbit around the Sun is unique compared to that of other planets. It takes an astonishing 248 years to complete a single orbit, and since its discovery in 1930, it hasn't even finished one full orbit. However, Pluto's orbit is more than just lengthy. It has an elliptical shape, which causes it to travel much further from the Sun than the other planets. Perhaps the most striking feature of Pluto's orbit is its significant tilt, about 17 degrees from the plane of the solar system, which makes its motion much more erratic compared to the other planets. What's even more fascinating is that Pluto's orbit overlaps with Neptune's for about 20 years during each orbit. For a period, Pluto actually moves closer to the Sun than Neptune. This raises an important question. Why hasn't there been a collision between the two celestial bodies? The answer lies in the gravitational interactions among various planets, especially those in the outer solar system. When Pluto was first discovered, astronomers noticed that its orbit was unlike the circular orbits of the other planets. Its highly inclined and erratic motion puzzled early scientists, and further investigations revealed that Pluto's orbit intersects with Neptune's. Yet despite the seemingly chaotic nature of these paths, Pluto's orbit remained stable, preventing a potential crash with Neptune. The reason for this stability is a complex interaction of gravitational forces, often referred to as the three-body problem. This refers to the challenge of predicting how three celestial bodies, such as Pluto, Neptune, and the Sun, will interact due to their mutual gravitational pull. A key factor preventing a Pluto-Neptune collision is a concept known as non-concurrent libration, meaning that when Pluto crosses Neptune's orbit, it is always at least 90 degrees away from Neptune, ensuring their paths never meet. Another important element is orbital precession, the movement of a planet's orbit in a vertical direction. In Pluto's case, its orbit is tilted in such a way that it avoids Neptune's path by staying either far above or far below Neptune's orbital plane. A third critical factor is the VSK wobbling, named after three researchers who studied the gravitational influence of multiple celestial bodies. The wobbling effect demonstrates how the Sun, Neptune, and Pluto's gravitational forces interact to maintain a stable orbital configuration. Despite Pluto's seemingly erratic orbit, this wobbling motion helps preserve its long-term stability. In the late 1980s, numerical simulations revealed that although Pluto's orbit may appear chaotic, small changes in its initial conditions would result in vastly different trajectories over long time spans. Despite this unpredictability, simulations confirmed that Pluto's orbit is stable over extensive periods. The gravitational forces of giant planets like Neptune, Jupiter, and Saturn play crucial roles in maintaining this stability. Interestingly, Pluto's orbit is in a special resonance with Neptune. For every 2 orbits Pluto completes, Neptune completes 3. This gravitational lock ensures that even though Pluto's orbit crosses Neptune's, a collision is impossible. This resonance adds an extra layer of protection, preventing Pluto from entering Neptune's path. Jupiter's immense gravitational influence also significantly stabilizes Pluto's orbit. With Jupiter's powerful gravity, Pluto remains on a relatively consistent course, and Saturn's gravity further contributes to the system's balance, making a catastrophic collision between Pluto and Neptune highly unlikely. These forces combine to create a system of remarkable stability, keeping Pluto safely on its course. However, even with these stabilizing forces, the future of Pluto's orbit is not guaranteed. The outer solar system is constantly shifting, and small changes in the positions or velocities of these planets could disturb the delicate balance. An external influence, like the gravitational pull of an undiscovered planet or a passing star, or internal factors such as tidal forces, could potentially cause shifts in Pluto and Neptune's orbits, leading to unforeseen consequences. The relationship between Pluto and Neptune is dynamic. While current research indicates that a collision is unlikely, changes in the outer solar system could alter this equilibrium, showcasing the ever-evolving nature of the cosmos. Astrophysicists like Neil deGrasse Tyson have weighed in on the future of Pluto's orbit, emphasizing the ongoing mystery and complexity of celestial mechanics. Tyson, who played a key role in Pluto's reclassification as a dwarf planet, sees the study of planetary systems as a continuous journey of discovery. He views the evolving understanding of planetary dynamics, including Pluto's interaction with Neptune, as an opportunity to learn more about the universe. Tyson's perspective highlights the unpredictability of space. While he acknowledges the stabilizing forces at play, he also cautions against overestimating the stability of Pluto's orbit, expressing caution about potential dramatic changes in the future. Will Pluto eventually collide with Neptune, or is this yet another cosmic puzzle to be solved? Only time will reveal the answer. Despite the complexities of their orbits, Pluto and Neptune remain captivating subjects for study. The potential for a catastrophic event between these two planets raises significant questions about celestial mechanics and the forces that govern our solar system. Understanding these dynamics provides invaluable insights into how planetary bodies and other celestial objects interact and how small shifts in one part of the system can have profound effects on the entire system. While the potential for a Pluto-Neptune collision remains a topic of intrigue and concern, the intricate gravitational relationships between them, coupled with the stabilizing influence of Jupiter and Saturn, make such an event unlikely. As scientists continue to study the motions of these planets, they will refine their models and enhance our understanding of the solar system's mysteries. With ongoing observation and advancements in technology, we may gain deeper insights into the forces that prevent Pluto from colliding with Neptune, or perhaps uncover new variables that could change the entire picture. While the possibility of a catastrophic Pluto-Neptune collision continues to captivate astrophysicists, it is essential to explore the intricate mechanisms that preserve the stability of their orbits. The gravitational resonance between Pluto and Neptune, which locks their orbits into a stable pattern, offers a strong safeguard against any potential collision. This celestial dance ensures that while their orbits may intersect, they will never come too close. This mechanism underscores the complexity and precision of the universe, where even the seemingly chaotic paths of distant planets can be in perfect harmony. The significance of understanding these gravitational interactions becomes even more evident when considering the role of other massive planets like Jupiter and Saturn. Jupiter's enormous gravitational pull plays a vital role in preventing Pluto from deviating too far from its designated path. Without this stabilizing force, Pluto's orbit could become more erratic, heightening the risk of an encounter with Neptune. Saturn's gravity also helps to maintain the balance, securing Pluto's position in the outer reaches of the solar system. This intricate balance of gravitational forces creates a carefully orchestrated system that prevents dramatic events, such as a collision between Pluto and Neptune. However, this delicate equilibrium is not immune to change over vast periods of time. The positions and velocities of celestial bodies can shift, which is where the concept of orbital precession comes into play. Small, gradual changes in the orbits of planets and moons can accumulate, potentially altering the dynamics of the solar system. These shifts could be triggered by external forces, such as the gravitational pull of an undiscovered planet or a passing star, or by internal factors like the gradual decay of orbits due to tidal effects. While the current state of the solar system appears stable, scientists are aware of the potential for long-term changes. As technology advances, astronomers will continue to refine their models and observations, enhancing our understanding of the forces that govern planetary motion. With each new discovery, the mysteries of space become clearer, and we gain a better understanding of the complex interactions that prevent a Pluto-Neptune collision. The future of Pluto's orbit and its relationship with Neptune remains an open question. Despite the current stability of their orbits, the outer solar system is dynamic and ever-changing. Understanding the long-term behavior of these planets requires continuous study and observation. As we gain more knowledge about the forces at play, we may uncover new factors that could influence the future trajectories of Pluto and Neptune. The case of Pluto and Neptune highlights the complexity and unpredictability of space. Despite the vast amount of knowledge we have accumulated about our solar system, there is still so much to learn. The study of these celestial bodies serves as a reminder of the vastness of the universe and the many mysteries that remain hidden, waiting to be revealed. The potential for a Pluto-Neptune collision, though unlikely, serves as a fascinating example of how small changes in the cosmic balance can have far-reaching consequences. It also underscores the ongoing need for further exploration and study to deepen our understanding of the universe we inhabit. In conclusion, the idea of a Pluto-Neptune collision raises important questions about the stability of the solar system and the forces that maintain its delicate equilibrium. The gravitational interactions between Pluto, Neptune, and the other giant planets in the outer solar system work together to prevent such an event from occurring. However, the possibility of changes over time, whether due to external forces or gradual shifts within the solar system, ensures that the dynamics of the cosmos remain an area of constant study. As science progresses, we may uncover even more about the intricate relationships that govern planetary motion, helping us to better understand our place in the universe. As we continue to explore and observe the solar system, it becomes evident that even stable systems are subject to change over time. The potential for unforeseen forces to influence planetary orbits cannot be ignored. The complex relationships between Pluto, Neptune, and the other celestial bodies in the outer reaches of the solar system are constantly under study, and with every new discovery, we gain further insight into the delicate equilibrium that exists between these distant planets. This ongoing exploration serves to remind us of the unpredictability of space and the vast unknowns that still exist. Even with our advancements in technology and understanding, the cosmos remains full of mysteries that challenge our current knowledge. In the case of Pluto and Neptune, the possibility of a collision may seem improbable, but it is not entirely outside the realm of cosmic possibility. The study of these potential interactions, how the gravitational forces of various planets influence each other, helps us to better understand the fundamental laws of physics that govern the behavior of the universe. Each new discovery, whether it supports or challenges our existing models, contributes to a more complete picture of how celestial bodies interact with one another. This continuous learning process is a cornerstone of modern astronomy, providing a deeper understanding of not only our own solar system but also the larger universe beyond.